Long before cameras reached the deepest parts of the ocean, scientists noticed something that made little sense. Maps of the Pacific kept revealing the same anomaly, a narrow scar stretching across the seafloor, descending far deeper than anyone expected. The numbers were so extreme that many assumed the measurements were wrong. Yet every new survey pointed to the same conclusion. Somewhere in the western Pacific, the surface of our planet dropped away into a darkness deeper than any mountain was tall. From above, there was nothing remarkable about the location. Endless blue water extended toward the horizon. Cargo ships crossed it. Storms passed overhead. Yet beneath that ordinary surface existed a place so isolated that reaching it remained one of humanity's most difficult journeys. And the depth was only the beginning. This was not simply a valley hidden beneath the ocean. It was an environment where sunlight had never existed, temperatures hovered just above freezing, and the weight of nearly an entire ocean pressed downward with a force capable of crushing almost anything humans had ever built. Imagine lowering Mount Everest into the trench. Even its summit would still remain more than 2 kilometers below the ocean's surface. For decades, many scientists believed such an environment could support little, if anything, at all. They were wrong. As technology improved and explorers finally began pushing farther into the abyss, the trench revealed something far more extraordinary than a hole in the seafloor. It exposed an entirely different world, one that challenged assumptions about where life can exist, how our planet reshapes itself, and what may still be hidden beyond human observation. But before anyone could understand the creatures living there, they first had to answer a more fundamental question. What force could create a place this impossibly deep in the first place? Everything hidden inside the Mariana Trench begins with a collision that no one can see. Hundreds of kilometers below the Pacific, the Earth's surface is moving so slowly that a person standing above it would never notice. Yet over millions of years, that almost invisible motion has opened oceans, raised mountain ranges, and erased entire landscapes from the face of the planet. The trench is one place where those hidden forces finally reveal themselves. Scientists eventually realized that the extraordinary depth was not created by a single catastrophic event. It was the result of an ancient process unfolding over tens of millions of years, one that continues beneath the ocean today. One of Earth's largest tectonic plates, carrying some of the oldest oceanic crust on the planet, slowly approaches the edge of another plate. This section of the Pacific Plate has spent nearly 180 million years cooling, becoming denser and heavier than the younger crust surrounding it. Then something remarkable happens. Instead of remaining at the surface, the Pacific Plate begins to bend downward. Almost imperceptibly at first, it disappears beneath its neighboring plate and sinks toward the mantle. The Mariana Trench marks the beginning of that descent, a visible scar created by an invisible collision. Imagine a conveyor belt so enormous that each movement is measured only in centimeters per year. To a human observer, it would appear completely still. But leave it moving for millions of years, and it can reshape an entire planet. That slow transformation turned the trench from a strange feature on an ocean map into evidence that Earth is constantly rebuilding itself. But this collision did more than create the deepest place on Earth. It created an environment where almost every assumption about survival would eventually be tested. The two plates do not simply slide past each other smoothly. They grind, lock together, and continue pushing with unimaginable force. Pressure builds silently over decades, sometimes centuries, until the rocks can no longer resist. When they finally break free, the stored energy races through the Earth as earthquakes powerful enough to shift coastlines within minutes. The same process creates another consequence. As the descending crust sinks deeper, increasing heat and pressure release fluids into the surrounding mantle. Portions of that mantle begin to melt, producing magma that slowly rises back toward the surface. Across the western Pacific, chains of volcanoes exist because of the same collision carving the trench below. Suddenly, the Mariana Trench was no longer just the deepest point in the ocean. It had become a window into the forces that continuously reshape our planet, and a place where nature was about to reveal how far life could be pushed. Yet understanding how the trench formed only created a more difficult question. If Earth could build an environment this hostile, what kind of machine and what kind of human would willingly descend into it? Knowing the trench existed was one challenge. Reaching it was another entirely. Unlike climbing a mountain, every meter downward makes the environment less forgiving. Light fades within a few hundred meters. The water grows steadily colder. Outside the hull, pressure increases relentlessly until it becomes strong enough to collapse steel, shatter glass, and destroy complex machinery in an instant. By the time a submersible reaches the bottom, nearly 11 kilometers of ocean lie above it. It is difficult to imagine that distance. Yet every square centimeter of the vessel must withstand the crushing weight of an entire column of water stretching all the way back to the surface. Engineers faced an uncomfortable reality. There was almost no margin for error. Early deep-diving vehicles had to be built more like armored vaults than submarines. Every window, seal, and weld represented a possible point of failure. A flaw too small to notice near the surface could become catastrophic several kilometers below. Despite those risks, in 1962, explorers committed themselves to a journey that few believed was possible. Their destination was a place no human had ever truly experienced. For nearly 5 hours, their small submersible descended through layer after layer of increasingly silent water. Radio communication became limited. Outside the tiny viewing ports, daylight disappeared completely, replaced by endless darkness broken only by the vehicle's own lights. Then even those lights seemed to reveal almost nothing. There were no landmarks, no horizon, no sense of direction. Only drifting particles suspended in black water and the unsettling awareness that an entire ocean rested above them. Then a violent sound echoed through the pressure hull. One of the outer viewing components had fractured. Inside the cramped cabin, the crew had only incomplete information. Instruments still appeared functional. The vessel remained intact. Turning back would have been the safer decision. But it would also mean ending the mission before discovering what waited below. They continued. Hours later, the submersible finally reached the seafloor. Fine sediment rose around the vehicle, swallowing the lights in a cloud of pale dust. For a moment, there appeared to be nothing but an empty plain stretching into darkness. Then the particles slowly began to settle. Movement. Not the giant sea monsters imagined in old legends, but something far more extraordinary. Clear evidence that complex life had survived in a place where many scientists once believed survival was nearly impossible. The descent had answered one question, but it immediately created a much larger one. If evolution could solve the impossible here, what other secrets had been waiting in the darkness beyond the reach of every previous expedition? Reaching the bottom of the Mariana Trench answered one question. Life could exist there, but it immediately raised another that was far more difficult to explain. How? Researchers eventually encountered one of the trench's most remarkable residents. A small, almost translucent fish moved across the seafloor nearly 11 kilometers beneath the surface. The Mariana snailfish did not look like a creature built for extremes. It was not large, it was not powerful. It looked surprisingly fragile. Yet it had accomplished something that challenged the limits of biology itself, surviving in one of the harshest environments on Earth. So how was it possible? The answer was not brute strength. It was adaptation. For millions of years, life in the deep ocean had been quietly solving problems that surface organisms never faced. Cells developed specialized molecules that remained stable under crushing pressure. Flexible bodies replaced rigid structures that were more likely to fail. Metabolism slowed to match an environment where food could arrive only occasionally from the distant surface. Life here had learned that survival was not about speed. It was about endurance. But the snailfish was only part of the story. Hidden within the sediments and mineral-rich rocks were microscopic organisms following a completely different set of rules. They did not depend on sunlight. Instead, they survived through chemical reactions connected to Earth's interior, creating energy in a world where the traditional foundation of almost every ecosystem, photosynthesis, was completely absent. Imagine an ecosystem that has never experienced sunrise. For billions of years, generation after generation has lived and disappeared in permanent darkness, powered not by the sun above, but by the chemistry of the planet below. That discovery changed one of biology's oldest assumptions. Perhaps sunlight was not the requirement for life that scientists once believed it was. Suddenly, the Mariana Trench became more than the deepest point in Earth's oceans. It became a place where scientists could study possibilities that extended far beyond our own planet. Beneath the frozen surfaces of distant moons like Europa and Enceladus, enormous oceans may exist without ever seeing daylight. If chemical energy can support ecosystems here, could similar environments exist somewhere else in the solar system? The trench had become far more than an ocean trench. It had become a natural laboratory for one of humanity's oldest questions. How many different ways can life exist? And that question leads to an even bigger mystery. If a place this extreme can support entire ecosystems hidden from the surface world, what else might be waiting in the vast regions of the deep ocean that humanity has barely explored? For all the technology humanity has created, the deepest ocean remains one of the least understood places on Earth. We have sent spacecraft across the solar system. We have photographed distant worlds, landed robots on Mars, and observed galaxies billions of light years away. Yet beneath the surface of our own planet, enormous regions of the seafloor remain unexplored in detail. The Mariana Trench is a reminder that discovery is not always limited by distance. Sometimes the greatest barriers are the ones hidden directly beneath us. Every expedition into the abyss returns with fragments of a much larger story. Cameras reveal unfamiliar creatures appearing for only a few moments before disappearing back into darkness. Instruments detect unexpected chemical signals rising from the seabed. Sediment samples uncover microorganisms adapted to conditions that once seemed impossible. And almost every answer creates another question. Scientists now study these extreme organisms for clues that could transform medicine and biotechnology. Geologists examine the trench to better understand the forces responsible for earthquakes and volcanic activity across the Pacific. Engineers continue developing materials and machines capable of surviving environments that challenge the limits of human design. But exploration also brings a difficult responsibility. The same ecosystems that reveal some of Earth's greatest secrets may be damaged before we fully understand them. As interest grows in extracting resources from the deep ocean, scientists face a question with no simple answer. How do we explore a world we barely understand without destroying the mysteries that brought us there? Perhaps that is the true lesson of the Mariana Trench. The deepest place on Earth is not important simply because it is the lowest point on the planet. It matters because every journey into the darkness forces humanity to reconsider what we thought was possible. For centuries, life was imagined as something dependent on sunlight. The deep ocean proved otherwise. The seafloor was once considered an empty wasteland. It revealed entire ecosystems hidden from human eyes. And today, after decades of exploration, the most surprising discovery may not be what we have found. It may be how much remains unknown. Far beneath the calm surface of the Pacific, ancient plates continue their slow descent into Earth's interior. Strange organisms continue surviving under crushing pressure. Evolution continues experimenting in environments where no human has ever lived. The deepest ocean is still writing a story we have only begun to read. Because somewhere in that darkness, beyond the reach of our cameras and machines, there may still be discoveries waiting that could change our understanding of life, our planet, and perhaps even where life might exist beyond Earth. The greatest mystery of the Mariana Trench is not how deep it is. It is how much deeper our understanding still has to go.